Let me sincerely thank you for joining today's session. It's going to be a routine thing now that will be releasing, and then just subscribe to this channel so that you can get updates whenever a new video is uploaded, you get a notification. So today we'll be looking at introduction to data analysis in monitoring and evaluation. For people that are just joining for the very first time, I think it will be necessary for you to meet the presenter. My name is Olugbinga Shalu. I have a wide range of experience in research, in monitoring, in evaluation, in surveillance, and in program management. I have written and published quite a number of scientific articles in scholarly journals. I've presented some of my abstracts and papers at conferences. I am the convener or founder of the Monitoring and Evaluation Mentorship Network, which has more than 50,000 members on Facebook and also on WhatsApp. I routinely teach research methods, data analysis, and also scientific writing. So today we'll be talking about data analysis in monitoring and evaluation. So the objective of this very brief session, I don't intend that this video goes beyond 30 minutes so that you can get a very highly summarized and concise and detailed concept of data analysis in monitoring and evaluation. So the objective is to provide an overview of data analysis and interpretation to introduce you to the different types of data analysis methods that we have, and then for you to have understanding on the basis for selecting the appropriate statistics. So we can't start talking without first touching on what variable is. And it's simple. A variable is a phenomenon with difference or with difference in magnitude. So it's an entity that you can assign a value to, and it varies from one person to another. For example, my height is not your height. So our height varies. So a height is a variable. My age is not necessarily your age. So if you look at the age in you that you are listening to me and my age, there's variation. So a variable is something that have difference in magnitude. You can assign different values to it. And we have two classes of two types of variables. We have variables that we can quantify and variables that we can just explain. So for example of variables that can be quantified, I've mentioned quite two of them already. So when we talk about numbers, when we talk about percentage, when we talk about means, those can be quantified. So a weight, which is in kilogram, depending on which SI unit you are using. A height, which could be a meter or feet or centimeters. The BMI can be quantified. Systolic blood pressure can be quantified. Your age or age at first marriage can be quantified. Then for qualitative, it provides more information, but it varies from one person to another. For example, if people are not using contraceptive method, there are different reasons. Why am I not using it? Or how am I using mine? So that qualitative gives you a reason for using or not using a particular method, and it doesn't assign a quantitative value into it. I'm sure we will be diving deeper into quantitative and qualitative in this series, because the goal is for you to have proper understanding. So you ask me, Why all this frenzy about data analysis? Why should we analyze our data? Well, for researchers, it is good for you to analyze your data so that you can get answers to your research questions. Before you embark on a survey or on a research entity, there are some questions that you have in your mind. It is when you have data and analyze your data. If you remember from the first video on data quality, we talked about data collection, data collation, data analysis, data interpretation. So you need to be able to know what your data is saying. So for us to be able to answer our research questions, it is good for us to understand how to appropriately analyze our data, because you're able to know what is the distribution of the various characteristics. For example, if you collect your data, so how many males do we have? How many females do we have in this particular study population? What is the what is the what is the what is the educational qualification of the respondents in a particular, and those are some of the reasons. So you want to know, okay, what is the age range or age group? Is this survey being answered mostly by is it answered mostly by youths or by adults, or is it more amongst um, or young female or young male, or is it largely around or amongst children? You also want to see the variance in the data. So how does these attributes, or how does this response, how does it vary across geopolitical zone? Are you seeing a pattern different in the southwest of a country compared to a north central of a country? So then also, we need to also see the differences within the data. And then what relationship do we have between or among the different variables? Is there a correlation between educational status and age? Is there a correlation between educational status and the amount that you earn? So data analysis will help you to be able to answer those questions if you have the questions in your research. Also, when you analyze your data, it makes it meaningful. The next series, I'm going to be more practical. I'll be showing us some data sets that will try to analyze it and summarize it and see what it will be showing us. Then you'll be able to see some salient features. What are the things that are hidden in between the raw data? And then you'll be able to understand distribution of these characteristics in the responding population. I want to believe that you are following me. I don't want to lose anyone. I want you to assimilate those things that I've mentioned, why we need to do data analysis. Then there's a concept also in data analysis that we call measurement. So the way variables are measured is very, very, very important. And that's why later we'll be talking about the different levels of measurement that we have. Measurement is the assignment of numbers to a variable. You remember that we explained what a variable is, that a variable is a phenomenon that actually takes different values and varies from one individual or from one entity to another. Then measurements will help us to assign numbers to a variable, and the purpose of measurement is to give it a size or extent or magnitude. So measurement determines the choice of the appropriate statistical method that we are meant to apply to that particular, to answer that particular question for that particular variable. I hope you're following me. Excellent, great. So measurements provides the value for magnitude or size or extent of any phenomenon or variable. It provides basis for comparison. And in statistics, we have 4 levels of measurement. We have it's it's higher than each other. So we have nominal, which is the first and the lowest level of measurement. We have the ordinal, we have the interval, and then we have ratio. Excellent. So we're going to be taking it one after the other. The first one, which is nominal variable, it classifies an object or a person into 2 or more categories. We cannot quantify or even rank or order those categories. For identification purpose, so nominal variables are often represented by numbers at times so that we can be able to do easy data analysis. So members of a category have at least one common characteristic. For example, one good and simple example of a nominal variable is the sex of human beings, male or female. A male is not higher than a female is not higher than a male. But when we get to deeper data analysis, if you want to perform some analysis, you need to assign either one or two to each of them so that you can be able to run your analysis, because you can't leave them at the state of male and female. You need to recode it and make one to be 1 or make one to be 2. Maybe male 1, female 2, or female 2, male 1, so that you can run your analysis. Because we get to that level when we try to do some analysis and we're able to divert that. But sex is one example of a variable that is at a nominal level. It can't be quantified, it can't be ranked, but we can use it for identification. So we know that in a sample or in a data set, we have male or female. So we can use for disaggregation. We can use to put them in different categories. Excellent. The next one is the ordinal variable. Ordinal variable is we are able to rank actually at this. So it allows us to rank the items we measure. So the intervals between these ranks are not actually equal. So you will get what we mean when I give you some example and explain further. So people or objects with a higher scale value have more or some attributes. So the ordinal scale is the second level of measurement. And I mentioned that the first level of measurement is the first level is nominal, the second level is ordinal. So an example of this is actually education. So we can have 4 groups of education. So we can have no education at all as the first in the ordinal variable. We can have another category that is just primary school holder. We can have secondary school holders, and we can have tertiary school or certificate holders. So the distance between the primary and the secondary is not equal to the distance between secondary and the tertiary. So that's why it is just ordinal, it's not at interval scale. So when we get to interval, I will explain further so you can know the difference between these things. But it's ordinal, there's a order. So the first level in I give you level of education. So primary school holder is more educated compared to someone who does not have a certificate at all. A secondary school holder is more educated than a primary school holder, and also more educated than someone who does not have at all. A tertiary school certificate holder, degree holder, is more educated compared to a secondary school holder, compared to a primary school holder. So that's the order that we see in the ordinal variable. And when we are doing analysis, we can also assign numbers to them to be able to differentiate, so that when we're doing some analysis, we can. So when we're assigning numbers to them, no education could be 0, the primary could be 1, the secondary will be 3, while the tertiary will be 4 when we're doing analysis, but you understand this better. For example, so we could use the rating of student performance, either poor or fair or good. You agree with me that good is better than fair and fair is better than poor. So that's how the ordinal variable is. Next is the interval variable, which is actually, this one is also ranked, but rank order is possible. Because, for example, the example I'm going to use is that the difference between 8 and 9 is 1. It's the same difference that we have between 76 and 77. So that interval is real. The interval in that level is real. Excellent. So let's go to ratio scale. Ratio scale is the highest level of measurement. It has all the properties of nominal, ordinal, and interval. It has a true 0 point. Ratio of any two numbers is meaningful. Yeah. And the starting point does not depend on units of measurement. So each numerical interval is 1 unit of that measurement. And we can also recode this to become ordinal, while all arithmetic operations, mean, median, and mode, can be applied on a ratio scale. Excellent. So I want to give you this based on the explanation that I've given on the levels of measurement. So I would appreciate you in the comments section to try to answer these 5 questions. So the marital status of a woman or of women, is it a nominal variable? Is it an ordinal variable? Is it an interval variable? Is it a ratio variable? So identification number of a study participant, the ID number, what is it? That's that ID number that it could be 001, 002, 0003, your matric number, if you're a student, your staff number, if you're a staff. So what level of measurement is that? Is it nominal? Is it ordinal? Is it interval? Is it ratio? Also the class size. So length of infants at ANC clinic, length of days, length of number of length of infants, sorry, so length of infants at ART clinic, meaning that you know, it's talking about the length of stay. I should have actually edited this better. So take note that it's length of stay of infants at ANC clinic. So a child goes to see a clinician, and then we are capturing the length of, just to look at quality of service, length of stay. So is it 1 day, was that an admission, or was it just for 2 hours or 3 hours? Those numbers, those continuous number. So at what level of measurement is that? Then your matric number as a student, or as a student, what level of measurement are we going to? So I'll be checking the comments to see if you actually got these 5 questions right, so that then we can also interact. You can also comment on other person's submission, so that we see if we are all on the same page. So why is measurement important? It informs us the way you design your instrument. When you know which level of measurements, either nominal or ordinal or interval or ratio, whichever level of measurement that variable you are trying to track falls in, you're able to design the appropriate instrument for it. So also, you know the type of data to be collected, because you know the level in which that variable is going to be analyzed. Then what you want to do with the data will determine the kind of data that you collect. So variables naturally quantitative should not be categorized to avoid loss of vital information. For example, a lot of mistake that people do is when they design questionnaires, although they are going to be making a lot of sense from age, when it is in different, so we have different groups. We have children, we have adolescents, we have young adults, we have adults. So they would have categorized it in that questionnaire. It's wrong. You can collect the exact age, maybe age at our last birthday in years, while you recode at your level of analysis. With that, you have richer information. So that's kind of data collection of age in years as a last birthday is at the ratio scale level where you can perform any other. You can even, I mentioned when I was explaining, you can categorize it and turn it to ordinal, because obviously somebody that is in the age, someone that is in the you can turn to category. Someone that is in the age range of 21 to 24 is older, obviously, than someone that is between 10 and 14. Yes, but if you collect the real age, you can look for the mean, you can look for the mean, you can look for the median from the data set, entire data set, you can look for the mode, you can categorize and then turn into categorical variable. So some of the things that we make mistake that we should not that we should guard against. And that's the purpose of this. So there are two types of analysis that can be done. There's the descriptive analysis, there's the inferential analysis. Descriptive analysis is simply trying to summarize your data. So you want to be able to describe it. You want to know what percentage of people are female compared to male, what percentage of your population is married compared to single, what percentage of your are from a particular part of the country compared to the other, how many persons from a particular educational status responded compared to. So it is summarizing your data, knowing. So that's why most of the time the information you get from descriptive analysis goes into the frequency table or social demographic table, where you're able to summarize it and then describe what the data looks like. And that's what most people do at the level of program implementation, tracking of some of the indicators. But at the more academic and predictive level or forecasting level, or at the deeper research level, you do inferential statistics where you make inferences. There's a test of association at that level. You're able to associate and correlate variables together. You're able to say categorically that there's this particular pattern of behavior amongst this population compared to the other. You're able to test for association. You're able to test an hypothesis, either accept the hypothesis or reject or fail to either reject the hypothesis or fail to accept the hypothesis. So that's the level of inferential statistics. And there are three levels of analysis that could be done. Also, univariate analysis, where you only work on with one variable alone, looking for the frequency of the variable, looking at the percentage or proportion of the variable. Bivariate analysis, now you are working with two different variables. Then multivariate analysis, you are working with three or more variables. So the different methods of analysis that you can do, you can tabulate. You can tabulate your responses. You have your rows and you have your columns, where you present your output in a tabular form. So, but always know that your table must always have a heading, so that people can know, well labeled, well titled, so that they can know what is contained in the body of that table. Then also you can do cross tabulation, where you correlate two different variables. You want to see, so most importantly, you hear about 2x2 table, you hear about the 2x3 table or 3x3 table. That is cross tabulation. For example, you might want to see marital status among, marital status, maybe single, amongst the different age group. Or you might even want to see educational status and correlate with the different age group. So then you can also do sex, either male or female, among the different age groups. So that's one of the easiest cross tabulation you can do. So you can look at the different age group, maybe 0 to 5, maybe 6 to 20, then you correlate it with male or female, and then we see. So we're able to know how many male, what's the age distribution amongst male, what's the age distribution amongst female. Also, you can do aggregation. You can add individual units to an overall picture. You can also disaggregate. You can break down into different units. You can also project. This you can forecast. For example, you can look at you can look for a particular variable and see how for example, you can look at, let's use an example, maybe your monthly sales. If you're a business person and then you track the number of items that you sold, maybe the only thing you do for, okay, another, I think let me use that as an example. In the month of in the year 2020, you have looked at how much you sold every month. So we have 12 months there. In 2021, you saw how much you sold for a particular item every month, January to December. And we're already in October. You want to know what you will sell in the next 1 year. With that information that you have over the last 24 months plus about 34 months, you can actually forecast your average monthly sales based on some statistical principles. You can use time series forecasting analysis to look at what they change over time. Where are you? So one major area where we've used time series analysis has been in COVID, uh, for the COVID forecasting. We used to have at that time daily number of cases. Looking at the last 21 days, cases daily for the last 21 days, you can actually project what is likely going to be the trend. In fact, that function is available in most of the global spreadsheet that we use, where you can forecast and it can give you a direction if things are coming down or things are going up, using insight from the previous data that you have aggregated or that you have in your database. Univariate analysis, the first task of data analysis is to examine the distributional characteristic of each of the variables under investigation. So an example of variable analysis is to come up with a frequency table, count the number of times some various responses actually occur. Then you could also present in your table the mean, the median, and mode. Those are examples of univariate analysis. And when we talk about uni, it's talking about a single. So univariate analysis is actually single variable analysis. When you hear about bi, so bivariate analysis actually involves two variables, just two variables. So example of them is a cross tabulation. And the popular way of testing an association between a cross tabulation is to do a chi-square. Also, between two variables, you can also do a t-test if they are two continuous variables. If there are two categorical variables, age and sex are categories. If you want to do a bivariate analysis of those categories, you could use a chi-square to test the association in that particular. But if you're looking at two continuous variables, you want to look at, so you can do a t-test. You can do a bivariate correlation also to see if there's a strength of association between maybe the age and height. Also, you can do a t-test between a before and after. Then, so because your choice of method depends on the measurement of your variables. We'll be touching on some of the things you need to look at to decide the kind of analysis that you will do. The multivariate analysis that involves employing relationship among three or more variables. Most of the times we don't get to this level of multivariate analysis until you have been able to ascertain there's an association between those variables. So you want to look at the strength of the association rather than just the direction of the association. A bivariate analysis, you can see the direction of the association, but in multivariate analysis, you can actually see the strength of these. But we need to be cautious in multivariate analysis because there are a lot of assumptions that is involved. Those assumptions, we're going to touch on a few, while you are going to get the benefit of having a deep dive in subsequent uh, lectures. So these are examples of multivariate analysis, multiple regression, logistic regression, log linear regression, factor analysis, discriminant analysis. So how do you choose appropriate statistics? So, people talk about ANOVA, NW ANOVA, ANCOVA, bivariate regression. There are actually assumptions and conditions to be met before you go ahead and use them, because statistics can be garbage in, garbage out if you are not careful. So the possible effect of a single non-metric independent variable on a metric independent variable, then you can do a one-way ANOVA, a one-way analysis of variance. That's what we call ANOVA. So when you want to look at the effect of a single non-metric independent factor on a metric dependent factor or dependent variable, you need to take note of that. Then when you want to look at the simultaneous effect of different non-metric independent variables on a metric dependent variable, that's when you use analysis of variable. So another advance, so you need to actually look at this critically, these conditions. So another variant of is the analysis of covariance, where the independent variables involved in this, you want to look at their effect. They can be either metric or non-metric. They can be continuous or non-continuous variable, independent variables on a single metric independent variable. So that metric independent variable, that metric dependent variable must be a continuous numeric variable. So another one is bivariate regression analysis. It's used to look at the possible effect of one metric independent variable on a single metric dependent variable. That's bivariate regression analysis. We have a couple of them also. Another one we need to look at is a multiple regression. Multiple regression is looking at the effect of two or more metric or continuous variables on a metric dependent variable. Then Pearson correlation coefficients, also used to look at the extent of relationship between two metric variables, between the extent of the relationship between two metric variables. Why binary logistic regression analysis is helping us to be able to look at the effect or possible effect of both metric and non-metric variables on a dichotomous dependent variable. So the dependent variable in a binary logistic regression analysis must be a dichotomous dependent variable. And you remember I gave you an example of a dichotomous. So an example of a dichotomous based on this context is either when you ask a question and it's yes or no. You will not use yes or no for this analysis. You will need to assign one with either 0 or 1 or 1 or 2. But for this level of analysis, we always use 0 or 1. So it must either be yes or no, male or female. So that's what dichotomous dependent variable is. Then also for multinomial logistic regression analysis, this is looking at a possible effect of both metric and non-metric variables on dependent variable with more than 2 categories. So multinomial logistic regression analysis is a variant of the binary logistic regression analysis, why the binary logistic regression analysis must have a dichotomous dependent variable, either yes or no. The multilinear logistic regression analysis can have different categories. So an example could be age group or educational status, either no education 0, primary education 1, secondary education 3, and tertiary education 4. So if you have to test the possible effect of either a metric or a non-metric associated variables on a dependent variable that has more than 2 categories, you use a multinomial logistic regression analysis. I want to believe that you are following and that you understand this conversation. The possible association between 2 categorical variables, I mentioned it earlier on when I was using the example of age group and sex. If you want to look at possible association between 2 categorical variables, use a chi-square test. If you want to look at the differences between a metric dependent and a non-metric dependent that has just 2 categories, when you want to look at differences between a metric dependent, a continuous variable that is dependent, and an independent variable that is not metric but has only 2 categories, you use an independent t-test. So I want to test your memory. So if you are to test for the difference between a metric dependent variable and a non-metric dependent variable that has multiple categories, more than 2, what are you going to use? You are going to use ANOVA. Excellent. But once there are only 2 categories of the non-metric independent variable, use a t-test. But if you have more than 2 categories, you use an ANOVA. Also, you can test for difference between 2 metric variables in a pre and a post test design. So for example, if I was to train you now and I gave you a pre-test and I scored it over 100, and we have about 200 people in this class, if I took your scores from the 200 of you at the beginning, and then after this particular lecture, I administered the same question again, and I asked you to answer this, and then you answered it. So I can compare the difference in your performances from pre and post by using a peer t-test. That peer t-test will help me to see if there's a significant difference in your knowledge at the beginning of this lecture and at the end of this lecture. Also, there's also beta coefficient, which is measuring the relative importance of the metric independent variables on a metric dependent variable. So when you want to see how important or what is the influence of a metric independent variable on a metric dependent variable, you can use beta coefficient to interpret the relative importance. Also, okay, I think an extension of the beta coefficient is coefficient of multiple determination, that's R-square, which is measuring the proportion of variations in a metric dependent variable explained by a metric independent variable. Also, for log linear analysis, is looking at possible association among 3 or more categorical variables. You remember that if you are looking at possible association between just 2 categorical variables, we are talking about using a chi-square. But if we are looking at the test of association between 3 or more categorical variables, we are looking at log linear analysis. Then there's a concept you also get to know eventually, that our data might be normally distributed or not normally distributed. So that's where we come about having a parametric test for a normal distribution and a non-parametric test for a a distribution that is not normal. So most of the very popular statistical method that we know are actually used for when we have a normal distribution. So in some points, we're going to take that lecture also testing for normality of your data set. So just ensure that you have all this in your kitty as you walk along with us. So we have, for every parametric test that we have, there's always an alternative non-parametric test that will give us the same results, but we are going to be using those ones because the data is not normally distributed. That's why we are going for the choice of those kind of analysis, because some of the things you need to do once you have your data is to first do pre-screening and then see if they pass the normality test. If not, nothing to fret about. There are alternative statistical methods that will be used if your distribution is not normally distributed and they are tagged non-parametric statistical test. So an alternate to an ANOVA is the Kruskal-Wallis test. An alternate to the independent t-test, if your data is not normally distributed, is Mann-Whitney. While the alternative to peer t-test, you remember the pre and post test design that I mentioned. If your data is not normally distributed, then we use the Wilcoxon sign ranked test. How do you interpret your p-value? A lot of things in the scientific publication, everything is about t-value, 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 t-value. Simple interpretation, but I'm sure we'll delve more into this in subsequent lectures. So interpreting your p-value. When your p-value is below 0.01, so that means you have very strong evidence against the null hypothesis, you will reject the null hypothesis. So if it's even between 0.01 and 0.05, that's moderate evidence against your hypothesis, and you reject your hypothesis. So for example, if your hypothesis says there's no difference between age of male and female, if that's your hypothesis, and your p-value after doing analysis shows us that it's less than 0.05, so you will reject that because it means that there is a significant difference between the height of male and female. If your hypothesis said there's no significant difference between the height of male and female, and your p-value after analysis shows that it's less than 0.05, you will reject that null hypothesis that said there's no difference. And you will say there is a significant difference, or you will see there's a significant difference between the heights of male and female. So if it is between 0.05 and 0.1, so that means well, there might be an evidence against but once it's above 0.1, there is no real evidence against your null hypothesis. In the course of these lectures, we'll be looking at different quantitative data analysis softwares, such as R statistics. In fact, there's an extensive, about 5 video lectures on R on this page. So if you are interested in understanding how to use R, I partnered with an amazing statistician and researcher, Dr. Stephen Balogun, who has taught a comprehensive 6 hours, 5-session lecture on R. So if you want to know how to use R statistics for analysis, you have it available already on this channel. Then for Stata subsequently will be advertising for lectures on live lectures on how to analyze data with the use of Stata. We currently have one running now that started a while ago. Once we run that one off, we will advertise so that those interested will actually partake in it. You get free statistical software Stata, free Stata 50.0, you have it. Then also you'll be taught how to analyze your data using Stata. Also, you will get videos of past lectures and the current lectures. So by the time you watch those videos, just like you're watching this already, you will become a very competent analyst using Stata. Also, we run classes on SPSS. We'll get to understand how to use SAS, Python, and SQL in the course of this broadcast. I think with that, we've come to the end of today's lecture on introduction to data analysis in monitoring and evaluation. It's been an absolute pleasure delivering this lecture in the past 47 plus minutes. I look forward to reading your comments, your answers to some of the questions that have been asked, and then you can make inquiries. Drop it in the comments. You are sure that somebody is going to respond to it. Thank you, and see you at the next broadcast, which is going to be more interesting than this because you have a lot to learn. Thank you, and thank you.